Hello, and welcome to the TI Precision Lab video on interchangeability. In this video, we'll discuss the definition of interchangeability and how it relates to temperature sensing. We will also address some design considerations in finding truly interchangeable sensors. In a simple definition, interchangeability is when we have two components that are similar and can be changed reliably with no impact to the overall system. To begin the discussion, let's start with why interchangeability matters. In some applications like medical devices and heat meters, need to have the ability to swap sensors or probes to avoid damages or to meet industrial standards for reliability. In such cases, it is imperative to avoid recalibration or reprogramming of the sensors. In other instances, having multiple suppliers available for products with a long lifetime is needed. The main considerations for interchangeability are mechanical specs, like package size and pin configuration, electrical specs such as power or interface, and software compatibility, which is not guaranteed by having compatible mechanical and electrical specifications. All these considerations are key while maintaining or enhancing the reliability of the system. Each temperature sensor manufacturer provides specifications in the datasheet. However, it is important to note that these specs as described in the datasheet can vary from one vendor to another. This especially makes it hard to easily interchange sensors from different vendors unless they follow a common standard that clearly defines the specifications for the sensor. A good common example for interchangeable devices are Wi-Fi devices. These are truly universal regardless of the manufacturer because they follow the same standard. We will now look into some examples and discuss how interchangeability applies in temperature sensing applications. If two temperature sensors are interchangeable, then by swapping them within a system, the system performance will not change even across extreme conditions. Additionally, there should be no need to recalibrate the system. Let's use the industrial standard temperature sensor as an example. The first step is to look at the mechanical compatibility. Here we compare the industrial standard LM75B and the more recent TMP 1075 to discuss interchangeability. The pins indicating function are similar. Looking deeper into the function, we see the similarities. Notice, however, that the power supply voltage on the TMP 1075 is extended to also support down to 1.7 volts. In this situation, based on the assessment so far, the LM75 can be interchanged with the TMP75. However, if your design used a TMP 1075 at sub 3 volt supply voltage, it cannot be interchanged with the LM75. With this preliminary assessment, let's look deeper into the mechanical specifications. More specifically, the packages. The two datasheets include package drawings. As you can observe, the mechanical specifications are identical, providing ideal footprint compatibility. The same device is also available in a much smaller package. However, from a mechanical standpoint, it's not interchangeable. If there is a board redesign opportunity, the system can benefit from further size optimization. Now let's take a deeper look into the mechanical specifications for interchangeability. Multiple temperature sensors may look similar. However, this doesn't mean that these sensors actually are. This is primarily because each vendor has their own internal standards when it comes to specifying electrical specs. An example of this is typical, minimum, and maximum values. Some vendors may refer to design simulations to guarantee these specs as well, while others may have detailed comprehensive test data and characterization. Also, min and max distribution limits may vary, which may result in wider limits than what is stated in the datasheet. Let's once again look at our industry standard temperature sensor. We see that the LM75B has an accuracy of 3 degrees Celsius between negative 55 degrees Celsius to 125 degrees Celsius. The TMP 1075 at the same operating range can provide a higher accuracy. Now let's consider the original application based on the LM75 operating in a range of negative 40 degrees Celsius to 110 degrees Celsius. By interchanging the TMP 1075, the system can now benefit from an accuracy of 2 degrees. This not only indicates that the devices for the specification of accuracy is interchangeable, but also indicates the added benefit of achieving higher accuracy, which can improve the system performance. It is important to also notice here that the typical accuracy spec is mentioned. In this case, the typical values are measured at an ambient temperature of 25 degrees Celsius, and the supply voltage is at 3.3 volts. Having only this spec is not sufficient to make a decision on design. Some vendors only mention typical, while others mention a min or max alone, and some vendors specify both. Through mechanical spec assessment, we can determine if the component can be swapped. Through a deeper analysis of the key electrical specifications, one can assess if the system will continue to function as expected. Should it be determined that the two sensors are truly interchangeable, the final step would be to assess if these two sensors are software compatible. In this example, given that we have considered a digital temperature sensor, we must check if the register sets are the same. With the LM75B, the configuration register is 8 bits, while the TMP1075 has a 16-bit configuration register with support for a single byte read and write over the I2C interface. Due to this feature, the device enables software compatibility. Should this feature have not been implemented, it is likely that the software would need to be rewritten. With implementing interchangeability, it is very important to not compromise on the reliability of the system. As we initially discussed, sometimes in applications like medical or heat meter probes, there is a need to replace the sensors. It is also important that the sensor performance is repeatable from unit to unit, and this electrical specification is not always called out in the spec table. Here you see an example of consistency in the measurement, which ultimately enables reliability for the application. Thank you for watching this video on temperature sensing interchangeability.